Hi, this is Igor. I will briefly summarize my research in the last school year. My research is to explore the extension of the available geophysical data of the Mid-Continent Rift in order to answer the question, after 1 billion years, to what extent the known structures can still be represented in the data. Due to time limit, I will only show two datasets, gravity anomaly and Rayleigh waves phase velocities. With these two datasets, we know the Mid-Continent Rift has a positive gravity anomaly, as you can see on your left, while the phase velocities are lower than the surrounding crust, as you see on the right. So I started with a simple model with all the known features of the rift. In this cross-section on your left, we have a 2D example of the 3D structure that I'm modeling. So we have here the sediments and volcanic rocks, brown and green respectively, and the magmatic root in blue, at the lower crust and upper mantle boundary. Each part has its own signature on the data. On the right, we have the gravity anomaly, with the negative anomalies for the sediments and the magmatic root, while the volcanic rocks have a positive anomaly. All these three features together, in some extent, will produce the gravity anomaly of the Mid-Continent Rift. Of course, several solutions could explain the gravity here. That's the reason why we combine more datasets for the region. So the next slide, I'll be presenting a little bit of the two different periods of the Rayleigh wave velocities. So following the same example of the gravity anomaly, I simulated the phase velocities map for each feature of the region. Here we have two periods, 10 seconds and 20 seconds. More are available, but for this moment, I will present the two frequencies. However, in the model, only the densities of the rift layers were different from the crust. What this means? So all the elastic moduli or stiffness of the rift were the same as the crust. So the only variable here is actual density, pretty much like the gravity. This was enough to reproduce low surface waves velocities as we seen in the previous, like the first slide. So there are some speculations that the Mid-Continent Rift has a mid-crust anomaly, but so far the higher densities itself could explain the lower surface waves velocities. So you can see here we have two blocks, one block at 10 kilometers, another block at 15 kilometers. So there's some speculations that we may have the second case instead of the first one, but the first one was enough to explain what you're seeing there. Maybe other datasets can say something different. Soon more details will be available.